again, so today we're going to be working on classifying conics, figuring out what shape they are from the general form. And then also we're going to look at how to find the eccentricity of a conic. Just looking at that definition of an eccentricity. Eccentricity basically is a measure of how circular or uncircular a curve is. It's just a number, and if someone looks at that number, they can tell, oh, it's very circular or it's not very circular. The least circular out of all of our shapes is actually a hyperbola, whereas a circle is the most circular out of all of our shapes, right? Yeah, definitely. A circle has an eccentricity of 0, and then we go up from there. Guess how I remember a circle has an eccentricity of 0? So it looks like a 0. Yes, a circle looks like a 0. The bigger the eccentricity number gets, the less circular the shape is. So ellipse is slightly larger than 0. Parabola is, that number would be slightly larger than the ellipse. Hyperbola would be the largest number. You can actually look in there. The eccentricity of an ellipse is going to be a number that's less than 1. The eccentricity of a parabola is exactly 1. And then the eccentricity of the hyperbola, which should be the largest number, is going to be a number that's greater than 1. And then there's a tiny little equation that we use to find it. The eccentricity number is given by the tiny little equation E equals C over A. And that's only for an ellipse and a hyperbola. The other two are always going to be either 0 or 1. Again, a circle has an eccentricity of 0. A parabola has an eccentricity of exactly 1. And then for an ellipse and a hyperbola, these are the two that we'll use our formula for. We'll take their C and divide it by their A value. And we get a number that's between, bless you, between 0 and 1 for an ellipse, and a number that's greater than 1 for a hyperbola. Bless you. Okay. So looking through. Can we tell what shape this first one is?
Yeah.
It's a parabola. How can you tell it's a parabola, Paul? There's only one squared term, right? And the only conic we had that had one squared term was parabola. So I'm going to write that down as a parabola. And parabola is one that we don't have to calculate. The eccentricity for a parabola is just 1. Yep. The second one is in a standard form, the one underneath it. This one is in a standard form. Can we tell what shape that is? It's all based on, there's a middle sign in the middle. It's not a circle. It's an ellipse. Yes. If we look at all of our standard form, that's what standard form of a circle looks like. Standard form of an ellipse looks like fractions where there's a plus sign in the middle. Hyperbolas have fractions, but there's minus signs in the middle. So for this one, it is an ellipse, which means we'll have to calculate the eccentricity. E is going to be a C over A. And if we go back to our formula, A is always the larger of the two denominators. So looking at my two denominators, this is my A squared. This is my B squared. So I'm going to need my C in order to find out the eccentricity. Do you remember how to find C for an ellipse? Yep. A squared minus B squared. Again, if there's a plus sign in the actual equation, you're going to subtract to find your eccentricity. So our C squared will be 100 minus 36, which is 64, which means C is 8. Yes, good. Okay, so when we plug those into our formula, we'll have to put our C over our A, which would be 8 over 10. Good, because A squared is 100, so A is 10. That does reduce to 4 over 5. Just double checking for an ellipse, we should get something that's between 0 and 1. Is it? Yeah, 4/5 is between 0 and 1. It's 0.8. Can we tell what shape the third one is? This one is a circle, yes.
that same
Good job.
side?
So there's two squared terms and the coefficients are identical. We'll actually look at that. There's a little flow chart on the bottom to help us figure that out. When there's two squared coefficients, when there's two squared terms and their coefficients are the same, it is a circle, which means the eccentricity, the measure of how circular it is just 0. No need to calculate. You don't know, but I think that's really clever. It makes it easy to memorize. Yes. Oh, good way of saying it, Paul. So then what do we think the last one is? A hyperbola. Very good.
That's the bottom ones this time.
Hyperbola is very similar to an ellipse-looking equation, except there's a minus sign in the middle. One of the terms is negative. So we will need to calculate our eccentricity by finding C over A. For a hyperbola, A is always the first denominator. It doesn't change. It's not necessarily the largest of the two. It's just the first denominator. So my A is over here. Well, actually my A squared, which makes this my B squared. And Danny already told us to find C squared. What are we going to do?
Add them.
Add the A squared and B squared. Good.
That's 289.
It's 289?
Yeah.
Nice. Which is a perfect square. 17. So we'll substitute in our C and our A to our eccentricity formula and get 17 over 8, which does not reduce. Just double checking, it should be an eccentricity that is greater than 1. Is it? Yeah, 17 over 8 is greater than 1. Okay. Now just practicing how to identify a conic from its general form. I think some of us have kind of got it already, but we do have a flow chart just in case. There's also a different chart on your green paper to help you figure out which conic it is from its general form. Okay, first question I ask myself is there only one squared term? Because if there's only one squared term, what is it? Yep, it's a parabola. Okay, if there's not only one squared term, then we go to the next question. Okay, are the coefficients of the two squared terms equal? Are they the same coefficients on those two squared terms? I see them all. If they are the same coefficients, what is it? It's a circle. That's like the one we had up top where we had an x squared and a y squared. If not, then you go down to the next question. Do the coefficients of the two squared terms have opposite signs? Or is one positive and one negative? If one's positive and one's negative, it is a hyperbola, which has two squared terms where one of them is positive and one of them is negative. And then lastly, if you have two squared terms that have different positive coefficients, it's an ellipse. The ellipse will have two squared terms that have different coefficients, but they are both still positive. E-R-E-N-T, different positive coefficients. So on the back side, we're just going to kind of be reviewing. Actually, we're going to guess. We're going to do, and then we're going to review graphing a couple of the shapes. So just checking to see if we can figure out which conics these are from the general form.
Square. They have two square terms, and then they also have the same.
Which means it is a circle. Two squared terms that have the same coefficients makes it a circle.
Actually, have two square terms, but they're different.
But they're different signs. So it's a hyperbola. Good job. Two squared terms where one is positive and one is negative is a hyperbola. Yep, one squared term, parabola. Like I said, I feel like we've kind of talked about this throughout each shape, so it might not be super hard to catch on to it.
Learning, like, this is a really weird. Like, I get it, but it's weird that we're learning that it's.
I think they're fun, Danny.
We're learning it, like, this is just separate.
Yes, yeah. They're different variations of a. All right. For the next section, we're going to kind of review how to graph certain shapes. We're going to find the eccentricity. We'll find all the important information necessary for that shape and then sketch a little graph. So I can see on this one, it has 2 squared terms. So that means it's not a parabola. Those 2 are both positive, so it's not a hyperbola. And they have different coefficients, which means, what is it?
So it's ellipse.
It is an ellipse. Good job. Okay, so let's review how to complete the square on the ellipse. First thing we want to do is we want to group the like terms together. We want to move the constant to the other side. It doesn't look like y squared has any like terms to group with it. I'm going to take that negative 20, add it so that it's on the other side as a positive 20. So since I have 2 x terms, I know I'm going to have to complete this square here. But before I complete the square, what do I need to do? Take out, yes, the leading coefficient, which is a 4. Minus 4x plus blank plus y squared equals 20 plus blank. Okay, and then we'll take the b number inside there, which is negative 4. We'll divide that by 2 and square it, which is negative 2 squared, which is 4. What is 4 what I add to the right?
Multiply 4 times.
4 times 4, so we'll add 16 to the right.
But
Yeah?
I always thought it was an X.
Okay, I'm going to bring down my 4. I'm going to factor this perfect square, which should have 2 identical matching factors. X minus 2 plus y squared equals 36. Then what?
Divide by 36. Oh, divide everything by 36.
Divide by 36, right, because we want it equal to 1 for an ellipse.
And then the left side, it's the left one, we can like simplify into 1 over
1 over 9, good. The second one does not simplify, and the right one just turns into a 1. Equals 1. All right. So from there, we can find our key features. What was our first key feature?
So you have to find
The center.
the center.
What is the center HK going to be at?
0, 2, and 0.
2 and 0. Good, because the H is over here with the X. The K, which is 0, is paired with the Y. So I'm going to graph that center at 2, 0. Okay. And then remember, after that, we use the 2 denominators. Well, technically, we use the square roots of the denominators.
Find the endings of the.
Good job. So we'll use 3 in the X direction. 3 in the X direction. 1, 2, 3. And then we'll use 6 in the Y direction. So 6 up and 6 down. So 2 of those were called the vertices and 2 were called co-vertices.
Covered from the limousine.
Let's think for a second. Vertices are always the ends of the main axis, which would be the longer axis. So my vertices should be the top one and the bottom one, the ends of the longer axis. So one of them is going to be at 2, 6. The other one is at 2, negative 6. And then my co-vertices are the ends of my short axis. So one of them is at negative 1, 0. The other is at 2, 3, 4, 5, 0. Okay, and then there's one other piece of information we find for this. What is it? The foci, the part of the definition where every point on the outside is equidistant from those two fixed points. How do we find the foci?
A squared minus B.
C squared equals A squared minus B squared, right?
Is that different for different ones?
Yes, for a hyperbola you add. It's always the opposite of the sign that's in the equation. So if there's a plus sign here, we subtract. The A is going to be the larger denominator, so that would be C squared equals 36 minus 9, which is 27. So C is the square root of 27, which does simplify, because that's square root of 9 times 3.
Yeah.
Which would be
3.
3 square root of 3. Square root of 27 is about how much? Just so I can place it on my graph.
It's about.
Yeah, 5 point something, yeah.
5.1.
Yeah, I'll call that 5.1-ish. So they're going to be on the main axis, 5.1-ish from the center. So 5.1-ish up and 5.1-ish down. Remember, when you write their ordered pairs, write it using the square root, the 3 square root of 3. So for both of them, we went 2 to the right. So they both start with 2 comma something. Okay, and then we were at 0. And we went up 3 square root of 3. So it'd be a positive 3 root 3. And then for the other one, we went down 3 root 3. Down 3 root 3. Okay, and then the last thing we were asked to find is our brand new thing for today. The weird one. Eccentricity, remember, is going to be your E equals C over A, which we found both of those numbers already.
In eclipse.
Doesn't an ellipse have what? Ellipse to the front?
Yeah, it's always like some. You're right.
No, not for an ellipse.
Between 0 and 1.
Right, which means we have to calculate it. What is our C number? We already found it. 3 square root of 3. Yeah. What's our A number? It's 6, right? Should be the square root of the larger denominator. Does that reduce? Look at those two outside numbers. Would that reduce? Yes, turn into a 1 and a 2. So square root of 3 over 2. Which I'm going to assume is between 0 and 1. She's studying. All right, one more review question. I can see we have 2 squared terms. It is. How can you tell? They have opposite signs, right? Which means it's a hyperbola.
I do know. Oh, seriously.
Which means I'm going to arrange my terms so I can complete the square. It looks like we are going to have to complete the square for both x and y, because there's 2 y's and 2 x's.
4x minus 16x. Plus 6.
Hold on. I'm not going to skip steps. Okay. We'll have to factor out the leading coefficient for both the x and the y. For the x, it's just a 4 we're taking out. What are we taking out for the y's? -1. Good. Okay. So we're going to take the b number, which is -4. We'll divide that by 2 and then square it, which is 4. But what do I add to the other side? 16. Okay, then I'll take the same thing on this one. Spoiler alert, it's going to be the same. It'll be 2 squared, which is 4. But what do I add to the other side? -4. -1 times 4. Good job. All right. So I'm going to factor each. They should be perfect squares now, so we can just write it as 1 factor squared. What is that first factor for this one?
X minus.
Mm-hmm.
And this one is going to be X and plus 2.
Y plus 2. And the right side's going to simplify to just a 16 because the 4's cancel out. And then one last step, what would that be?
Divide
Divide by 16, yep, because we need a 1 on the right side. It's like that first fraction is going to reduce.
So 1 over 4.
Very good. That'll give me x minus 2 squared over 4 minus y plus 2 squared over 16 equals 1. Can we tell which way this one's going to face?
It's going to be up and down.
Which way does the x-axis face? No, the x-axis faces left and right, so it's going to be left and right. Yes, if x is positive, that means left and right. This one.
Oh, favorite word.
Which is left and right, yeah. All right, center. HK center, what's it at? +2, -2. Okay, I'm going to graph that center. Okay, and then we use our denominators to find edges of that center box.
4 is 2.
Mm-hmm.
16 numbers.
Good. So 2 in the x direction from our center. 4 in the y direction from the center. We'll draw our little center box in. What do we do with the center box now?
You
You
find it cross out. You find the
Asymptotes, yeah. Asymptotes through the diagonals to the best of your ability using an ID badge, a human geo card, or just a steady hand.
Really hate their bad.
I know, okay, listen, sometimes it's got, sometimes it's got. Big conversation. Right, yeah, so I know. Oh, that's just so nice to share.
Alright. Got my asymptotes drawn. Thinking about if it faces horizontally, out of these 4 points, which ones were the vertices then?
Or the left and the right.
The left and the right one, right. So if it faces left and right, your vertices are the ones on the left and the right. Which one is it? 0, -2.
2, 0.
What?
And the other is at 4, -2.
Okay.
And usually for hyperbolas, we don't write down the co-vertices, but if you put them, it wouldn't be marked wrong. What else? We can write down the equations of the asymptotes. And the foci we'll have to find yet.
We calculated. Really wide with them is going to be a
We can do point slope form.
right?
Yes. What would be the slopes of this? So go from the center to that top right corner. What would be that slope? Yeah, it would be 4 over 2, which is 2. So one side has a slope of -2, the other side has a slope of +2.
So we do plus and minus layers too.
Uh-huh.
We only do plus and minus -2 instead of hyperbola.
Okay, so we'll do y minus the y that they both go through, which is the center point. So y minus -2 would be y plus 2. They have positive and -2 for the slope. And then we'll do x minus the x of the center, which is x minus 2. You don't have to distribute it out. You can just leave it like that unless you want to distribute.
We also have to find the being.
We have to,
Like that eccentricity.
yes, we have to find the eccentricity and the foci still.
Also, didn't it between
A foci is going to be our c squared equals a squared plus b squared on this one, which would be 4 plus 16, which is 20.
20 doesn't have enough means. Or your paper, so it's gonna be 5 and 4, right?
Yes, so we'd write that as 4 times 5,
And then you take out the 4, then we get 2 on
2 square root of 5. But we do need an approximate so that we can graph it.
and because it's
Square root of 20 is about,
18, that's one.
no, 16 has a square root, it's 4.
It's gonna be like 4 point. Just put 4.3.
We'll call it 4.5, it doesn't matter. Okay, so when you have it horizontally sideways facing a hyperbola, those foci are going to be on the sideways axis here that goes through the center. Both of them are going to be 4.5-ish away from the center. 1, 2, 3, 4.5-ish. There's one. 1, 2, 3, 4.5-ish. There's the other one. I forgot to label the F's on my ellipse. Okay. We need to actually draw it now too. Don't forget we didn't even draw it. So we're gonna have one start at the vertex.
This one.
No, only on a parabola. Oh yeah. Okay, so I actually went home the other day, guys, and looked up the Latin translation of latus rectum. Everybody listen to my fun story. Lattice. Lattice translated in Latin meant wide.
Oh,
I know. But rectum, you're gonna be bummed about this one. Guess what rectum actually translates to? Straight.
What?
Yeah, it means straight.
Wide straight.
Wide straight. I know.
If the way was going, we're gonna go really well.
I know. But if anything, I still think about it as the width of the booty. That's what my brain always thinks. All right, last thing we gotta find eccentricity. For a hyperbola, do we have to calculate it or is it just given? We have to calculate it. It's c over a again. We know our c is 2 square root of 5. A is always, a squared is always your first denominator here.
And it
Right, we got it today.
Sure. Yeah.
Oh,
it's only work.
All of this stuff is going to be on the quiz, so it's nice to review it. Except for eccentricity. Does this reduce? Yeah. E equals
One of
square
root of 5.
what if we go to the
You can if you want to, but it's not on the quiz.
cheap thing. Not gonna do that. Extra one.
No.
Oh, you're gonna.